This video covers taking partial derivatives using implicit differentiation. The good news is that those two processes basically work the same here as they do separately.
If I have a function z, which I define implicitly as this equation here, x cubed plus y cubed plus z cubed plus 6xy equals 1. So z, I can say, is an implicit function of x and y. And now if I want to, I've told you that z is a function of x and y, and I'm going to take the derivative of z, the partial derivative of z with respect to x and with respect to y. Notice that in this definition, x and y are not related to one another. So as I take first the derivative of z, or as I look for the derivative of z with respect to x, what I'm going to do is implicitly take the derivative with respect to x of this entire expression. So I'm going to look at each term and remember that z is an implicit function of x, but y is not. So as I go through this, I take the derivative of the first term with respect to x. I get 3x squared. I look at the second term. Remember that x and y are unrelated, so the derivative of y cubed is 0. Z, however, is an implicit function of x. So I'm going to use the chain rule. I get 3z squared times the derivative of z with respect to x. So that's just an application of the chain rule. And now I look at my at my final expression, 6xy. I need to take the derivative of x is 1. Y is unrelated to x, so we can treat it like a constant. I get 6y is equal to 0. I can solve this expression for dx dy. I'm going to first move the terms to the other side. I get 3z squared dz dx is equal to negative 6y minus 3x squared. And then I'm going to get dz dx by itself by dividing by 3z squared. I get dz dx is equal to, I'm going to pull out this negative sign here, negative 1 over 3z squared. So I've just divided this 3z squared over to the other side times 6y plus 3x squared, having factored out that negative sign. Now, if I want to take the partial with respect to y, it's basically the same process, except now I'm taking it with respect to y. So I erase my x here. I say, okay, now my derivative is with respect to y. I'm going to implicitly differentiate the entire expression. Again, remembering that x and y are unrelated, but that z is an implicit function of x and y. So if I'm taking the derivative with respect to y of this first term, the derivative is simply 0 because x and y are unrelated. I take the derivative of the second term. I get 3y squared. I need to take the derivative of the third term, again with respect to y. And because z is an implicit function of y, I will use the chain rule. So I bring down the 3. I leave z squared, but I need to multiply it by the partial derivative dz dy. So I know that z is a function of y. I don't know what that function is, but that's okay. I simply write that I'm using the chain rule here, and whenever I know what z is, then I can worry about it. Or how z and y are related, then I would worry about it. I look at this third term. There is a y there, so I take its derivative. Its derivative is 1. x is unrelated to y, so I can treat it as a constant. So this is 6x times the derivative of y, which is 1, and then it's equal to 0. I want to now solve for the partial derivative dz dy, and at this point it's just algebra. It's very similar to the algebra we did before. I'm going to move both of these terms, the 3y squared and the 6x, to the other side. They are negative, and I'm going to divide everything by 3z squared to get dz dy by itself. The algebra there is the same as it was on the previous slide. So suppose you have this function this definition, this expression, it is not a function, where z is defined implicitly as a function of x and y. Again, x and y are unrelated. Go ahead and pause the video at this point and try it on your own. All right, so I'm going to take the first look for the derivative. So I'm looking for two partials, dz dx and dz dy. I'm going to start by taking the derivative of the expression with respect to x. This first term, the derivative of x is 1. Y and x are unrelated, so I can treat y as a constant. I just get y. In the second expression, y remains a constant, but z is an implicit function of x. So the derivative of z of x is 1, but I need to also multiply this by the derivative of the inside function, dz dx. Just to sort of sidebar that a little bit, if you are thinking about the chain rule, you have a function f which is a function of something else. And that's basically what's going on here. When you take the derivative of a function that is a function of something else with respect to that something else, with respect to that something else, x, you're going to take the derivative of the outside function, df dg, evaluated at g, times the derivative of dg dx. So here in this particular case, we have z, which is a function of x. So we take dz of x dx. The derivative of z with respect to z, so this is dz dz, is 1. And then we have dz dx using the chain rule. So we're left with just the dz dx. The second half of this expression, the other side of the equation, again, we're taking it with respect to x, but now we have two terms multiplied together, both of which are functions of x. So I need to use the product rule. I'm going to take the derivative of the first term, x. I get 1 times the second term unchanged, plus the first term unchanged times the derivative of the second term. We already found that. It's 1 times dz dx. So at this point, I have an expression that I need to solve in terms of dz dx. So I'll just go ahead and do the algebra here. I'm going to move the dz dx terms to the same side. I get y times dz dx minus x times dz dx is equal to z, and I move all of the other terms to the other side, z minus y. Notice that I could factor out on the left-hand side a y minus x dz dx is equal to z minus y. So I'm going to divide both sides by the y minus x, and I get dz dx is equal to z minus y divided by y minus x. Now to find the partial with respect to y, it's basically the same process. I'm just doing it with respect to y instead of respect to x. So I look at the first term. I treat my my x as a constant. The derivative of y is 1, so I'm left with just the constant x. Here, both y and z are functions of y, so I need to use the product rule. I'm going to get the derivative of the first term is 1 times times the second term unchanged plus the first term unchanged times the derivative of the second term. So that's all the derivative of yz is equal to, now x and y are unrelated, so I'm treating x as a constant. And the derivative of z with respect to y, I don't know what it is, I just write the derivative of z with respect to y. So now I have, again, two terms with dy dz in them. I'm going to get them on the same side. I get y plus z is equal to, and I'm going to do the factoring in the same term, dz dy times x minus y. Notice that the minus comes from me moving this term to the other side. Final step, I need to take dy dz by itself, so I'm going to divide both sides by x minus y. So I get x plus z over x minus y. So here's another example. Why don't you go ahead and pause the video, try it on your own, and then we'll come back and you can work it through. So I take the derivative of this first term with respect to x. Both x and z are functions of x, so I need to use the product rule. The derivative of the first term, of course, is 2x times the second term unchanged, plus the derivative of the second term, the first term unchanged times the derivative of the second term. Now, I don't know what the derivative of the second term is, so I just write it dz dx. So these two terms together are the derivative of that first term. For the second term, the y is not a function of x, so I'll treat it like a constant, times the derivative of z. I don't know what it is, so I just write dz dx. On the right-hand side of the equation, my y is basically a constant, and so now I have just the expression x times z to worry about. So I use the product rule once again. The derivative of x is 1 times z unchanged plus x unchanged times the derivative of z with respect to x. I now have a lot of different terms with dz dx's and without dz dx's, so I'll move all the dz dx's to the same side. I get x squared dz dx plus y squared dz dx minus xy, notice I've distributed that y in, times dz dx is equal to, I have yz on the right hand side minus 2xz on moved over from the left hand side. I'm going to factor out my dz dx. Don't do anything to the other side, leave it unchanged. And then I'm going to divide through so that I get dz dx by itself. I get yz minus 2xz over x squared plus y squared minus xy. And I'm done. The process taking the partial with respect to y is very similar. Here, now the first term has only the z as a function of y. So I treat the x squared as a constant times, I don't know what the derivative of z is, so I just write it down dz dy. Plus, the second term is a function, both of the terms y and z are functions of y, so I need to use the product rule. For the product rule, I take the derivative of the first term times the second term unchanged plus the first term unchanged times the derivative of the second term. I don't know what it is, so I just write it dz dx. So both of these together are the derivative of the second term. That's going to be equal to, now I'm trying to take the derivative of x, y, z with respect to y, but both y and z are functions of y, so I need to use the product rule. My x is unrelated to y, so I treat it like a constant. I just leave it out front. And I'm now going to use the product rule on y, z. The derivative of y with respect to y is 1 times the second term z unchanged plus the first term y unchanged times the derivative of the second term with respect to y. So at this point, I have a bunch of expressions with respect to dy, I'm sorry, that should have been a dy in the second place there. And I'm going to get all of the dz dy's by themselves and all of the expressions without a dz dy by themselves. So I'll move all the dz dy's to the left-hand side. I get x squared dz dy plus y squared dz dy equal, minus xy dz dy. And I'm going to move the 2yz to the other side. I get xz minus 2yz. I factor out my dz dy on the left-hand side. My right-hand side is unchanged. And then I divide through to get dz dy by itself. And I'm done.